Hi, good morning to all. Welcome back to the class number 3 of chapter number 1, operating system. Real-time operating system. The last class we have discussed about all the 6 points about the evolution of operating system like mainframe, batch processing, multiprogramming, time sharing, and the multiprocessor distributed operating. So today I am going to discuss about the real-time operating system. A real-time operating system, or which is known as RTOS, is a very popular operating system or is a multitasking operating system intended for applications with fixed deadlines, or you can say it is a real-time computing. Such applications include some small embedded system, automobile engine, controllers, industrial robots, spacecraft, industrial control, and some large-scale computing system. The real-time operating system can be classified into two categories. One is your hard real-time system, another one is your soft real-time system. Basically, the real-time operating system deals with that system where the time period is very critical. That means little negligence in this type of operating system, it causes the major damage in your system. So these RTOS applied the very into that system where the time period is very critical or time period is very sensitive, right? For example, your spacecraft, launching of spacecraft, aircraft, air traffic control, these are the things. So entire this real-time operating system is divided into two categories: hard real-time system and the soft real-time system. A hard real-time system is that it guarantees that critical tasks be completed on time, and this goal requires that all delays in the system be bounded. From the retrieval of stored data to the time that it takes the operating system to finish any request made of it, such time constraints dictate the facilities that are available in the hard real-time system. So basically the hard real-time system where any critical tasks will be completed on time, like the air traffic control, that the traffic is very that means it will be controlled on time. Next is your soft real-time system. It is a less restrictive type of real-time system. It is a real-time system, but here time period is somehow it is relaxed, right now. So a critical real-time task gets priority over other tasks and retains that priority until it completes. The C of soft real-time system can be mixed with other types of system. Due to less restriction, they are risk to use for industrial control and robotics. So, real-time system, generally soft real-time system generally is used in the railway reservation system where the time period is somehow it is restricted, but the maximum is not be restricted. But some point where the time period is very restricted, is very sensitive, in that case, in your hard real-time system is used. So from next, structure of operating system. Structure of operating system generally divided into simple structure and layer approach. In the simple structure, there are several commercial systems that do not have a well-defined structure. Such operating system begins a small and simple and limited system, and they grow beyond their original scope. So MS-DOS is an example of such system. That means this MS-DOS follows the simple structure of operating system. It is not divided into modules carefully. Another example of limited structure is the Unix operating system, MS-DOS structure. So these are the simple structures. Here are the application program, Here resident system program, MS device drivers and BIOS device drivers. So there is the layering, is not a layering architecture, it is a simple structure. Next is your layer approach. Layer structure is a type of system structure in which the different services of the operating system are split into various layers, where each layer has a specific well-defined task to perform, and it was created to improve the pre-existing structure, like the monolithic structure and the simple structure. In the monolithic structure Unix, each component of the operating system was obtained within the kernel and could communicate directly with any other component and had unrestricted system across, and this made the operating system very efficient. It also meant that errors were more difficult to isolate. That means in monolithic structure, but in this structure, suppose there is an error occur, it is very hard to identify the error, where is the error, or for which reason the error will come, right now. So that is, but in the layer approach, that is the in the case of the layering structure. This layering structure having there are the layer 0, layer 1 up to the layer n type of structure. So in the center of the part there is a microkernel architecture. This is the microkernel. This part is to include only very small number of services within the kernel in an attempt to keep it small and scalable. The services typically include low-level memory management, inter-process communication, and basic process synchronization to enable process to cooperate. Our microkernels are highly modular, making them extensively portable and scalable. Operating system components outside the kernel can fail without causing the operating system for all over. So next is what are the advantages of this layering architecture? Is very modularity, easy debugging. That means there is modular systems. So that's why it is very debugging. But debugging means to rectify the error, or it is easy to correct the error. Easy update, no direct access to hardware, abstraction. And the disadvantages: complex and careful implementation, and you can say the advantages is that the modularity. This design promotes modularity as each layer performs only the tasks it is scheduled to perform. Next is easy debugging. The layers are discrete, so it is very easy to debug in layering architecture. Suppose an error occurs in the CPU scheduling layer, so the developer can only search that particular layer to debug. Unlike the monolithic system in which all the services are present together, like the previous simple structure. Easy update. A modification made in a particular layers will not affect the other layers. No direct access to the hardware. The hardware layer is the innermost layer present in the design. So a user can use the services of hardware but cannot directly modify or access it. Abstraction. Every layer is concerned with its own function. So the functions and implementation of other layers are abstract to it, that is hiding. And each layer having own processing technique. So next is your disadvantages. Though this system has several advantages, over the monolithic. That also some of the disadvantages like complex and careful implementation, slower in execution. In the next class, we are going to discuss about the disadvantages for today's. Thank you.